Welcome to Security Explained, a new series where we break down the things every developer should know about keeping web apps safe. In this first episode, we're tackling the OWASP Top 10, the industry's go-to list of the 10 most critical ways web applications get hacked. Over the next few minutes, we'll walk through each one, what it is, why it matters, and how to defend against it. So let's start with the obvious question. Where do you even begin? You've built an app. You know it should be secure, but secure is a vague word. The list of possible attacks is basically infinite, and there's no universal priority list telling you what to patch first. That's exactly the gap the OWASP Top 10 fills, a ranked, expert-backed list of the 10 risks that actually matter most, built from real-world data. So here's the definition in one breath. The OWASP Top 10 is a regularly updated ranked list of the most critical web application security risks, maintained by a nonprofit, built from real-world incident data, and treated across the industry as the starting point for what to fix first. One important caveat, though, it's a baseline, not a complete checklist. Clearing the top 10 doesn't mean you're done. It means you've handled the risks most likely to hurt you. Before we go deeper, let's quickly answer who's actually behind this list. OWASP, the Open Worldwide Application Security Project, is a nonprofit that publishes free, vendor-neutral security resources. Every few years, they pull data from thousands of real applications and rank the risk categories that show up most often and cause the most damage. 4 things to remember. It's free and open. It's driven by real-world data. It's refreshed on a cycle, and crucially, it ranks categories of risk, not individual bugs. So here's the current lineup, the 2021 Top 10, which is still the active list. At the top, broken access control, cryptographic failures, and injection, the 3 categories behind a huge share of real-world breaches. Further down, you'll see newer entries like insecure design and server-side request forgery. We won't dive into every single one today. Instead, we'll focus on the heavy hitters, the ones most likely to bite your app first. Starting with the heavy hitter, broken access control. The app knows who you are, you're logged in, but it forgets to check what you're actually allowed to do. Classic example, you change the URL from user 123 to user 124, and suddenly you're reading someone else's data. The fix is a mindset shift. Deny by default. Verify authorization on the server for every single request, and never trust an ID coming from the client. Tie each record back to its owner and enforce that on the way in. Next up, A02, cryptographic failures. This is what happens when sensitive data, passwords, tokens, personal info isn't properly protected, either in transit or at rest. Think plain text passwords in the database, traffic flowing over HTTP, or someone's clever homegrown encryption scheme. The defense is boring on purpose. TLS everywhere, hash passwords with bcrypt or Argon 2, encrypt data at rest, and lean on vetted libraries. Never roll your own crypto. That brings us to A03, injection, the classic attack where untrusted input gets executed as code. Look at the vulnerable snippet. Glue a user-supplied string into a SQL query, and an input like apostrophe or 1 equals 1 quietly returns every row in the user's table. The fix is mechanical, not clever. Use parameterized queries so input is bound as data, never parsed as code. Escape output, validate input, and let your ORM do the heavy lifting. Next up, 2 failures that live above the code itself. A04 insecure design is when the blueprint is broken. No rate limit on login, no throttle on password reset. No amount of clean code saves a flawed plan. So threat model before you build. A05 misconfiguration is when the software's solid but the setup is wide open. Default passwords, public cloud buckets, debug pages in production. Harden your defaults, strip what you don't use, and grant the least privilege that still works. Now to 2 risks that often hide in plain sight. A06, vulnerable components. Most of your app isn't yours, it's libraries and dependencies. One outdated package with a known CVE, and you've inherited the whole. Scan regularly and keep things patched. A07 authentication failures is the flimsy front door. Guessable passwords, no brute force protection. Broken sessions, no MFA. Fix it with multi-factor, rate limiting, and solid session handling. Rounding out the list, A08, software and data integrity. Trusting code, updates, or CI pipelines you haven't verified, which is exactly how supply chain attacks land. A09, logging and monitoring failures. If you can't see an attack, you can't respond, and that ties directly into our observability series. And A10, server-side request forgery, tricking your own server into fetching URLs an attacker picked, often to reach internal services or cloud metadata. Now step back and look at all 10 together. There's a single thread running through them. Misplaced trust, trusting user input, trusting the client, trusting a default config, trusting a dependency, trusting that nobody's looking. Security, at its core, is the discipline of not trusting by default, and that collapses into 3 habits worth burning into memory. Validate every input, grant the least privilege you can get away with, and build defense in depth so no single failure is fatal. Before we move on, let's kill 3 myths that keep tripping teams up. First, clearing the top 10 doesn't make you secure. It's a floor, not a ceiling. Second, this isn't just a big company problem. Bots don't care about your traffic numbers. If you're online, you're a target. And third, security isn't something you hand off to a separate team. Most of these risks live in code and design decisions, which means every developer owns a piece of this list. So if every developer owns a piece of this, what does the baseline actually look like? On the do side, validate and sanitize every input, deny by default, and grant the least privilege needed. Patch your dependencies on a schedule and log security events so you can actually see what's happening. On the avoid side, don't trust client-side checks, don't roll your own crypto, don't ship default configs or passwords, and don't bolt security on at the end. Get these right, and you've raised the floor on most of the top 10 before we even dig in. Good habits get a lot easier when you've got the right tools backing you up. For dynamic scanning of a running app, OWASP Zap is the free option, and Burp Suite is the pen tester's classic. For dependencies, lean on NPM Audit or pip audit during development, and let Dependabot or Snike flag vulnerable packages in your repo. When you need guidance, the OWASP cheat sheets are pure gold. And as you mature, layer in SAST to scan your code and DAST to probe the live app. Let's pull the key takeaways together. The OWASP Top 10 ranks the most critical web risks, with broken access control and injection sitting right at the top. Nearly all of them come down to the same root cause, trusting something you shouldn't. So validate input, enforce least privilege, and layer your defenses. And remember, this list is a baseline to start from, not the finish line. Here's something worth noticing. The top 10 isn't a standalone topic. It threads through every other series we'll cover. Auth failures lead straight into JWT, OAuth, and session handling. Misconfigurations and vulnerable components point to Docker, Kubernetes, and infrastructure hardening. Crypto and injection tie back to how you store and query data. And logging failures connect to observability because you can't defend what you can't see. Security isn't a separate track. It's a layer over everything you build. So, where does this series go from here? Security Explained continues with deep dives into injection and XSS next, then authentication attacks, secrets and crypto, and hardening in practice. And if you want to move from understanding risks to actually closing them, the Dargslan hardening courses turn each topic into hands-on work: SSH, Kubernetes, Postgre, and AIE LLM security. Knowing is step 1. Doing is where it sticks. Before we wrap, I want to turn this back to you. Of the 10 categories we just walked through, which one has actually bitten you in production? Maybe it was injection in some legacy code, an S3 bucket left wide open, or a broken access control check that shipped on a Friday. We've all been there. Drop yours in the comments because the war stories are how the rest of us learn faster. That's a wrap on episode 1. This was the map, the lay of the land, and from here we go deep, one category at a time. Next up, we're cracking open injection and cross-site scripting, how they actually work, how attackers chain them, and the patterns that shut them down for good. Hit subscribe so it lands in your feed. Check out dargslan.com for the written companion, and I'll see you in episode 2.